Well, hello everyone. Hopefully everyone can hear me. I'd like to say thank you for taking the time out to come explore our new FiX1. So without further ado, I guess we'll go into the webinar. So I'd like to introduce the FiX1 from Carlson. As Anthony has stated, it's the fixed installation scanner for obtaining volumetric data of stockpiles and structures, stockyards, and mining operations. What is the FiX1? The fixed installation scanner, or as referred to as the FiX1 from Carlson, provides simple automated method for obtaining point cloud and volumetric data of monitoring areas and stockpiles in many different installation scenarios. It allows the analysis of the data and a variety of connectivity options to ensure continuous operation and multiple systems in a network. What is the FiX1 system? Basically, the FiX1 is a common web interface is provided across the three connectivity options. So you can connect via a wired Ethernet connection, Wi-Fi or cellular to the FiX1. The web UI presents a complete history of scans and volumes that the user can download if required. Scheduled scans can report completion and volumetric data via email. The web interface provides access to all the settings and diagnostics such as scheduling of scans, system performance, laser and motor configurations. Fault reporting can also be accessed through the web interface and alerts sent to the email. The software of the FiX1 is remotely upgradable through the web UI. And multiple system configurations can be configured and accessed through a single interface. The important thing to take away from these comments here is everything is on the web UI. There's no software that's installed on a local desktop or anything like that. So everything's controlled on board the computer that's built into the FiX1. As you can see here to the upper right portion of the screen, you can see the mount point, which is the apparatus that connects to the structure, which then connects to the FiX1. The blue piece down here is the integrated computer and comms. And on the back of it, you can see you have two antennas for both the cell and the Wi-Fi. The white body is where the housing with motors and electronics are stored. And then of course the laser heads at the end, which is pretty obvious which laser is. Volumetric data. When a volumetric scan is initiated, the FiX1 will generate a point cloud, extract the region of interest, and calculate the volume of the material in that area. The volume is recorded and displayed to the user through the web UI without any need for further manipulation or results received via email. So basically it's automated. Volumes can be verified by examining the linked point cloud data for foreign objects and anomalies. So if you do see something weird or an odd volume that does come out, you can interrogate the web UI and take a look at that particular scan. Volumetric accuracy can be user-defined through the setting of the laser and angular resolutions in the web interface. We'll talk about that more later. The web UI provides a graphical representation of how volumes have changed over time, as you see that through the charts and the scans. And data from multiple FiX1's systems is automatically stitched together based on references created during the installation. Therefore, total volume can be computed without the need for manual intervention. So if you have a multiple unit installation, say 4 or 5, say FiX1's in one area scanning the same area of interest, it will stitch all those scans together. The FiX1 does come in a unique situation where it's kind of a hub and spoke configuration. So when we do have a multiple FiX1 installation that is needed to scan larger stockpiles and areas effectively, the individual FiX1 system can be set to operate as a hub or a spoke mode. When a FiX1 is set to hub mode, it will act as the point of access control and central processing unit for the entire network of FiX1's that are present or that are in spoke mode. When a FiX1 is set to spoke mode, it will initiate scans once it receives the start signal from the hub FiX1. The spoke FiX1 will then send the point cloud to the hub FiX1. The hub FiX1 will then mesh all the collected clouds together at the hub and from the various spoke FiX1's into one point cloud, and from that combined point cloud compute the volume of all the collected scans. The key to this process is all the FiX1's must be geo-referenced to each other. So that means they all have to know where they are in relation to each other, otherwise you're going to have a bunch of nonsense. But to go back to this slide, the key thing is each FiX1 does have the capability to be a hub or a spoke. I think someone needs to mute their mic. There's some feedback coming across here. But anyways, that's important to know. Multiple zone volumes. So okay, wrong person got muted. Sorry about that. Um, so with multiple zone volumes, so each FiX1 has the capability of extracting separate volumes inside the one scan that are zones of interest. These can be from individual scans or FiX1 multiple installations. This is done by simply uploading a polyline file that contains the boundaries of desired areas, which will then be used to sort of cookie cutter the point cloud over the designated base surface. Now, a polyline file is a Carlson format file, but basically it's an ASCII text file formatted to contain XYZ information of the zone of interest. So you're going to see on the screen here, there's a simple visual display of what the polyline file looks like. And then on the right hand of the screen, you'll see one of our popular softwares, P3D, where you can actually create the polyline file create the base and such like that. So the FiX1 will work with multiple Carlson titles. FiX1 laser scanning. By default, all point cloud data is stored in the FiX1. This information can be downloaded from the FiX1 in the common LAS format later on if you so desire. Like the volumetric calculations, the resolution of the point cloud data can be configured through the Web UI. Point cloud manipulation and processing remains invisible to the user for regular operations, meaning you don't see it, you don't have to worry about it once it's set up. Automatic stitching of the point clouds in multiple scanner systems is carried out by referencing of each FiX1 during installation. So essentially everything is carried out at the beginning when the system is commissioned. Then if everything's working great, it's all seamless to the end user. Some key specifications of the FiX1. Now this will be important to determine how many FiX1s you have on site, what you need, what type of piles you can do. The maximum range for the system is 250 meters or 820 feet to a 90% reflective target. The minimum range is half a meter or 1.64 feet. The range accuracy is plus or minus 10 millimeters or 0.4 of an inch to a 90% reflective target. And the maximum measure rate is 15,000 points per second. Now, the reason why I mention a 90% reflective target is that in our factory conditions, and which most laser manufacturers will do, is it'll be to a 90% reflective Kodak paper. That's in a controlled environment. So obviously, if you are measuring coal or really dark or absorptive materials, you'll have reduced range. If it's wet, that will reduce your range as well. So you need to keep that in mind when you look to set out what FiX1s you need. Also, an important point of note is the FiX1 is a laser and is a class 1 laser product, meaning that it is eye safe. That is important to government organizations and some companies because they have laser safety rules. The total weight of the system is 12.5 kilograms or about 27.5 pounds. The size, the height and the width is about 495 millimeters by 314 millimeters or 19.5 inches by 12 inches. What's important to note this is for the installation is the rotational clearance. It needs about 368 millimeters or 14.5 inches. That's how much clearance where it can't interact with anything around it. So you have to think of that as like sort of the zone of exclusion. You can't have anything within that because it'll hit the instrument. Now, importantly for most of you people, the operating temperature. The minimum range is minus 40 centigrade, which is minus 40 Fahrenheit, that magic number, to 50 degrees centigrade, plus 122 Fahrenheit. So it has a wide range of operating temperatures. And also it's an IP rating of 67, which means it's dust tight and it can take splashing water. What is the base one, the FiX1 base system? What do you get? Well, basically everything's contained in one Pelican case. You get one Carlson FiX1, region specific. Now the reason why we say it's region specific is it does come with a cell modem inside of each unit. So each unit has to have the appropriate cell modem for wherever you are in the world. So there's 4 regional models, which you would denote at the time of order. Comes with a simple mounting plate, one FiX1 fixing kit, which a bunch of screws and stuff in there, a region-specific power cable, Ethernet test cable, 2 external Wi-Fi and cellular antennas, and the packing case itself. So as you can see, there's not much to the system. It's very self-contained and it's small. Now let's talk about the FIX1 Web User Interface. The FiX1 is very simply accessed through an assigned IP address that will work in any of the mainstream browsers. So basically Chrome, Safari, and such like that will not have an issue. The FiX1 system will ship with a static IP address so that customers' IT department can configure the FiX1 to work with the customer's network. Once they connect to the system, they can then be faced with a login screen for security. Basically, this is sometimes one of the most important steps, is interfacing it with your company's IT. As we all know, IT departments can be very strict and regimented, so this is where we can work with you and your IT department to make sure you have a seamless transition. Now with the system itself, there's two logins that you have. There's an admin login and a user login. The admin login gives you full functionality to the FiX1. It allows you to schedule scans, change the parameters for the scans, which we'll look at, and stop scans. We also have a user login, which is just basically a view and scan functionality, which you could let someone view the scans, start a scan, but they can't change any of the variables in there. This is to ensure that, say, for example, if you're the facility manager and maybe you want the loader to take a look at the scans, this just gives you the ability to allow someone to look at it but not interact or change the scans, because the last thing you want to do is have someone change the settings and then that could screw up everything. So the navigation. The FiX1 Web UI has a simple navigation ribbon at the top of the window. This ribbon will be displayed at the top of the window no matter which page you're in the FiX1 Web UI. The ribbon will display the serial number of the FiX1 and allow you to do the following: log out, scans. This is the default page that you go into when you log in. This is where you can see the current activity and past scans. The schedule. This will take you to a schedule window where you can configure future scans. Obviously the settings page. This is where you can configure the various settings of the FiX1s, and then the language drop-down menu where it allows you to select a variety of languages that this is available in. Now it's important to remember that this is all done on the web UI. There is no software you need to install locally on your machines. So you can access this, again, like I said, on an iPad, iPhone, Android if you want, your laptop, desktop, whatever. So the scan page is what you see when you first log in. It's a very simple interface. As you can see on the left hand here, this is in a tabular form. It shows you each of the scans, how long it ran, the zones, if you had zones of interest, and the respective volumes for each of those. You can also stop and start scans at the top. On the right hand of the screen is just a graphical way of representing the scans, and this way you can take a look and see trends and such like that. When you select on the scan history, you select one scan. This allows you to go a little bit deeper into the scan. It allows you to view the point cloud in a point cloud viewer. There's an onboard point cloud viewer that allows you to look at the scan in its point cloud form if you want. You can download all the data associated with the scan, which is the binary file, an LES file, a grid file, the actual volume report, or a full report which gives you some more statistics about the scan. You can delete the scan and you can reprocess the scan. The reprocessing is, say for example, you change something in the settings and want to reprocess to collect the data. You can do that. This is all on through the web UI. The report, this is what you will receive in your email, and this is pretty much what most of the people will be interfacing with the FiX1. Here's a standard report that the FiX1 generates. As you can see, it gives you some information about the site. In this instance here, in this salt barn, we had two areas of regions of interest, and you can see at the bottom, region 1 and region 2 can be individually labeled and give you the associated volume with that as well. Now the point cloud viewer, this will allow the user to basically go in, as you just saw on the screen, and view the collected data through the web UI. This is important, allows you to actually see what you're collecting, but also if there's some kind of anomalies in the volumes, you can go in there and you can take a look. And then that's just showing you the different surfaces that are created, the base surface and the bottom surface. So this is all that's done through the web UI. And again, you don't need to download this to your computer because it's all done through the web UI. The scheduling page, very straightforward, much like your Outlook or your Google. Here you can set up the frequency of scans, the dates, the repeat, and the hourly intervals. So you can have it scan every hour on the hour from now until infinity, or you can say I want to scan it every week at a certain time. These are all just done so that you could just set it for however you want to do it. So this is pretty standard and straightforward. And you can also run manual scans outside of this. The settings page. We're going to go through this fairly quickly. The settings page is just the nuts and bolts and the guts of the system. So when you get to the settings page here, you'll see obviously units, information, scanner, reporting, georeferencing, and so forth. We're going to talk about each of those individually. Each of them are accessed by simply hitting the right the arrow button that's pointing downwards, and that will expand the each of the sections. So the first thing is units. This is probably one of the most important settings here. Since we are an international company, we sell these around the world, we have to offer a variety of units. So the units drop-down section will allow the user to, on the volumetric units, allow you to choose cubic meter, cubic foot, or cubic yard. The length unit, the meter, the feet, and in the US, we have the US survey feet. The unit weight, kilogram, pounds, ton, which is that's a short ton in the US, and then the ton is the metric ton for the metric. And then you have the selection of using reporting units, volume or weight. You would want to select volume if you did not know the density, and you would select weight if you wanted to, if you knew the density, like tons per cubic yard or kilograms per cubic meter. That's where you would select either or. So if you don't know what the density is, you would just report the volume. And of course, the density section there has a lock and unlock. You can go in and put the value you want to do that. The next setting is the information page. This is generally just tells you some information about the unit. Important to note that temperature is the internal CPU temperature, so it's not the external temperature. Obviously, that'd be a very hot place. Give you some information about the CPU, what versions you're using, and such like that, and what type of updates and stuff. So typically, you're not going to go into this screen at all. The scanner page. All right, for the setting for the scanner. When the FiX1 is scanning, the body of the FiX1 rotates horizontally at a relatively slow speed, while at the same time the laser head rotates vertically at a higher speed, as you can see in the diagram here. The laser itself is firing constantly at a predetermined rate. The results is a pattern of radial scan lines drawn beneath the FiX1. The scanner settings allow you to adjust the density of the angle between the radial lines, the density that points along the lines, and the extent of the ground that the lines cover. And we're going to talk about each of these settings here. So you can set the vertical coverage. Well, first, before we do that, you notice at the top here, it says has estimated run results. Now this is important. As you adjusting the scanner settings changes the duration of each of the scans, as well as the number of points that will be collected. So usually the larger the area that each FiX1 needs to cover, the longer the scan duration will tend to be, and more points will be required to ensure that you have sufficient density of points to cover the areas of interest. So as you change the settings, you'll see in real time the duration of the scan changing the number of points. Now this is important because, say for example, if you want to scan every hour and you use settings that make the scan last an hour and a half, you're going to run into scheduling conflicts. So vertical coverage, just so everyone understands, is the vertical extents of the scan itself. 180-degree vertical coverage would survey everything up to the horizontal plane from the FiX1. Here's an example. When you put the value at 70 degrees, it covers an area of 70 degrees like that underneath the scanner. This can be tweaked to use that if you don't want to, say, if you have superstructure above the FiX1 you don't want to collect, you can limit the vertical scan extents. The horizontal coverage is pretty straightforward. 360 degrees goes around once, but you do have the ability to set it at 720 degrees so you can cover the area twice. And where that kind of helps is, for example, if you have trucks or people walking underneath you, they might appear in the first scan and might not appear in the second scan, and the software will then filter that out to try to get the lowest point from that. So that's why some people might decide to scan it twice or 720 degrees. The interval, this is basically the speed of how fast it scans in between. Right now you would set the value of, you go with default 21. That's sort of the increment between the vertical slices. So this is something that you would set once and never use it again. The head rotation, typically we have the head rotating at 450 degrees a second. That's the fastest that it spins at. You could slow that down if you wish to, if you're covering a larger pile, so that way you have a lot more data per swath that goes down there, then that's greater. That's a better thing to use if you're shooting at a pile that's longer and further away. And of course, the laser rate, the laser can be set at increments of 5 kilohertz up to 15 kilohertz, which is 15,000 points per second. Typically, everyone sticks at the 5 kilohertz range because they get you more than enough data. But if you are shooting a larger pile that is longer in a distance, it's got a greater area to cover, you might want to increase the laser rate just because you'll be shooting over longer distances, which then will get you a little bit more density. The reporting page, pretty straightforward here. Here's where you can set all your email alerts to whoever needs to be alerted for scheduled scans or alerts. Alerts would be, for example, you see down here in our threshold, if we say we want a minimum of 300 cubic yards and a maximum of 850 cubic yards, anything that comes from a scan that's outside that, that's greater or less than that, will be sent out as an alert. So that way some people only want to be alerted to if there's a change. And also there's a delta change alert. So if the volume is changed between scans greater than sort of, let's say, 5 cubic yards, that will trigger an alert email to go out as well. So you can, this is how you can determine who gets what. And also under the reporting options, you can give your company name, like Acme Corporation, and the site name as well. And most importantly, the time zone of the FiX1. Time zone is important, so that way if you're working with multiple units throughout multiple time zones, you'll see when you say you want to scan at, say, 4 p.m. Of the FiX1, it will be at 4 p.m. in that local time zone and not your computer time zone. The georeferencing page is pretty straightforward. The mounting plate, when you install it, which we'll look about shortly here, you put in the XYZ for it. And then the orientation, this is what we do through the commissioning. We determine what the azimuth offset, pitch offset, and roll offset. These are to tweak it to match your surface. And most importantly, is it mounting up or down? So if you have it on the roof looking down, you would have that deselected, but if you have it mounted on a pole looking upwards, you would have the mounting plate up selected. The base surface, this is important. If you're comparing the data against a pre-surveyed base, you would load it up here with the types of units. Also, you could load up your polylines. So in this case, we have 2 zones of interest. Also, then you can adjust the cells that are created to create the volume. And then, of course, angle of repose. This helps with our modeling software, so then when you get to areas that you can't see, for example, up against a wall, it's trying to use what the angle of repose would be to help smooth the data in areas that we can't see. Network setup options. Obviously with the FiX1, we have Ethernet settings. You can do enable Ethernet or dynamic Wi-Fi settings and cellular settings. You can delve deeper into those through training, but those allow you to set up how you want the system configured for connectivity. And management system, this is what we'll talk about at the end, the Carlson Ops. This allows you to connect your FiX1 to the Carlson Ops server, which, like I said, we'll cover that at the end of this presentation. And then, of course, you can set it up as a hub or a spoke. It defaults to none, but then if you set it to spoke mode, like we said before, or hub mode, like we said before, this is where you could do it. And then the calibration page, typically this is something that you won't use. These are factory defaults. These will be set up by the person commissioning the scanner when it's set up in your warehouse. And of course, languages. We cover a ton of languages, English, Spanish, French, Russian, Mongolian, Chinese, plus many more. I can't honestly tell you what half of those languages are on there, but apparently they do work. All right, so installation considerations. As you can see here, this is one of our good distributors here installing one of the FiX1's in a salt dome that we have for testing. But what do you have to consider when you're installing the FiX1? So you want installation line of sight. The FiX1 can only measure what it can see. So it's very important to take a look at what your target area footprint is, the height of the material. If you're in an area and you set up the FiX1 and the material gets higher than the FiX1 or close to the FiX1, you're going to have a lot of shadows behind that material that the FiX1 can't see over or through. And also obstructions. A lot of these might be on active mine sites, or they might have different types of feedings or cranes or belts or conveyor belts running through the scene or through the field of view. You have to make sure that you have the optimal placement of the FiX1 so that those obstructions are minimized. Because if you can't see it, the FiX1 can't see it, and if the FiX1 can't see it, it's not going to measure it. Also, you want to make sure it's on a stable platform to mount the FiX1. So you don't want to be hanging on something that's loose, so it's going to move. Because if it's going to move, like swing in the wind, or if it's on a platform that's mobile, like say for an overhead feeder, we're not going to know where it was at that scan. And what's going to cause it's going to be a problem when we start relating the scan to the base. So it has to be on a very stable and non-moving platform. But there are situations that we could talk about where you can put it onto a moving platform, but those are more specialized and require some updating of its position. You also want to consider the environmental effects when you set it up. Vibrations, you don't want to set it on top of a crusher that's going to be vibrating all the time during collection and even when it's not collecting, because vibrations over time will wear or tear down the equipment. Temperature, you want to make sure that it's an area that's within the temperature range of that minus 40°C to 50°C, but also you don't want to be putting it right next to an exhaust either, where you get big temperature differentials. So that's important. And moisture. It is rated for dust and splash proof, but obviously you don't want to mount it underneath a faucet or having water leak all over it, because that could affect the laser and over time add to erosion and corrosion of the device. Most importantly, connectivity, power and data. When you set it up, is there power and data available? You could get it to run off of batteries or some other power sources, but they will run out over time. So we always recommend go to mains power that you can switch on or off at a safe location, and also data connectivity. You have to be able to tie it into your network. And also you want to survey in the mounting plate if you can. But one of the more important things is it must be mounted on a horizontal level, plus or minus 1 degree, up or down. The reason for this is to make sure all the math works great, and also when you start to if you install it past that plus or minus 1 degree, there's more wear and tear on the rotation in the motors on the system. Here's an example of our FiX1 installation in Maysville, which was our test installation results. This is where obviously our corporate headquarters in Maysville, Kentucky. We had the FiX1 set up in the breezeway, sort of like a big garage, and we had it scanned there, surveyed everything, created a volume underneath it, and compared, and the results came out pretty spot on, 35 cubic meters to 35 cubic meters. So this gives you an idea of the details of the scan here. This is one of our really longer term important installations right now. This is a salt barn that we have the system currently installed in for monitoring. As you can see here, we have a video just showing what the salt barn looks like. In the upper right hand corner, you'll see a results of the actual data collected. Now as the video goes forward there, you can see the FiX1 scanning up there at the top. As it's scanning, there's LED lights that indicate its status. So right now you see a cascading or a cascading blue with a white light going across. That means it's collecting data and processing. But this is sort of a typical salt barn here in the US. As if you're familiar with them, obviously there's different constructions. So this shows you we mounted it up top. It's got a great field of view, and it seems to be working really good with everything there. The next installation we had a couple installations, is in China, an iron mine demo that we did. As you can see the results at the bottom that we got, they put a FiX1 over here as they're scooping out material, and they usually would have someone go up there with a total station to measure it every once in a while. So you can see what they mounted the FiX1 permanently over top on one installation here. And here's on this one, there's actually for the test site, they created a temporary mount. As you can see, it's scanning over top of it. They also have one installed outside as well, scanning the coal piles and such. So this has been a big success in China where we have a couple systems, and it's been invaluable to them. One of our first long-term ones was in Mongolia. Go figure, we go look for the most remote areas to install this. This was in an active mine, power plant actually in Mongolia. And as you can see, it's mounted in an area where they feed material into from the belts on the side, and then they have like a big giant claw that comes in and scoops out the material. And with our filtering algorithms, we're able to filter out the claw and filter out a lot of the other data and stuff that comes in there that we don't want. And we have a couple systems on the site as well too. This just shows you some of the different types of operations, from a salt barn to an iron mine, and then to sort of a power plant in Mongolia. Those are sort of the, oops, not too sure why that came across there. Anyways, so we're going to talk about the introduction to the Carlson Ops right now. So we're going to take a few seconds here to talk about Carlson Ops. This Carlson Ops is a real-time data management. Let me get rid of this here, sorry. Real-time cloud data management. So this gives you the power of the cloud and reliability of Carlson. So where Carlson Ops really is going to be coming into hold here, say for example, you have say you're a company that has maybe 10 FiX1's in your organization. What this will allow you to do through a simple web interface is to connect to each of those FiX1's And you can set up a hierarchy. Like, for example, you can see on here, they got me as the boss, monitoring Tim, Karen, and Bill, who have various FiX1's in their regions. So the FiX1's are connected to this, and then they're allowed to see what the FiX1's do. So you can see here as you get more of reporting results on the FiX1 on CloudOps, it can give you the individual data over time, see on a map where everything's in relation to. So for example, if you have a lot of barns that you're trying to map, you can look all the data real time here, different trends, and you can also bring in data from other reporting methods. Like for example, if you have a reporting system in your company where if you're bringing material in, say you had 10 truckloads come in today, you can manually input that and that will compare it against what the FiX1 is doing. So that's one of the good things about the Carlson ops there that we got coming out. Carlson Ops is also a very bespoke data-driven solution. So solution development, including in the bulk purchase of the hardware, it's highly reliable with a proven security and redundancy, and tailor-made AI systems to solve complex problems. So basically what we're saying here with the Carlson Ops is we can customize it for your individual needs. There's a lot of things that you can incorporate into Carlson Ops in conjunction with the FiX1, and that's something we can explore. Carlson Ops in itself is a whole different webinar because there's a lot of functionality, connectivity, and reporting things that you can do with it. So basically that brings us here to the end. Please contact your local Carlson representative for pricing and information. As you can see here, we have a pretty diverse and great sales team with pretty much a global footprint. I'd like to leave you guys all off here. Hopefully you guys can hear this. This is, you guys got any questions, but we also had the FiX1 that was mounted in that salt barn was featured in a local TV report a couple months ago, and it was pretty interesting. Like I said, the FiX1, the main thing to keep in the FiX1 is talk with your representative. The FiX1 can be used at a multitude of situations, not necessarily directly related to mining or say salt barns and stuff like that. Anytime you need to measure a volume of an inventory that you don't want to have a person go out there repeatedly do it, it's a great installation, and there's some other interesting ways it can be installed too. So please float the ideas by your representatives. That could be submitted to check with the FiX1 development team, and we can most likely take advantage and take care of any of your situations that you have.